Decode the instruction. The instruction decoder interprets instruction. If an instruction has an indirect address, the effective address is read from main memory and any required data is fetched from main memory to be processed and then placed into data registers. Execute the instruction. The CU control unit passes the decoded information as a sequence of control signals to the relevant function unit of the CPU to perform the action required by the instruction, such as reading values from registers, passing them to the ALU to perform mathematical or logic functions on them, and writing the result back into a register. If the ALU is involved, it sends a condition signals back to the CU. Store results. The result generated by the operation is stored in the main memory or sent to an output device based on the condition of any feedback from the ALU. Program counter may be updated to a different address from which the next instruction will be fetched. The cycle is then repeated. There are two main components of a CPU: the arithmetic logic unit ALU. It performs all arithmetic operations and decision making operations. Data transfer, which includes moving of data from one location to another within the computer. Arithmetic operation, it includes addition, subtraction, multiplication and division, etc. Decision making, it is an ability to compare two quantities and perform logical operations such as compare true or false, etc. The control unit CU, it extracts instructions from memory and decodes and executes them, calling on the ALU. When necessary, it controls all functions and coordinates all components of computer. It is in charge of fetch execution cycle. Function of control unit: control flow of data from input device to memory, from memory to output devices or secondary storage, from secondary storage to memory, from ALU to memory, from memory to ALU. Coordinate instruction execution: fetch the instruction, decode the instruction, execute the instruction. More components of a CPU that are vital to its operation are the registers, which are very small memory locations that are responsible for holding the data that is to be processed. Register is a small and very fast storage area inside CPU. It is used to store immediate values from calculations or instructions that is needed immediately. For example, when ALU is instructed to calculate A multiply bracket B plus C bracket close comma, ALU needs to calculate B plus C first, then ALU need to store the result for a moment and use the result to multiply A. It is faster for ALU to access register than store the data in the memory unit. There are 4 types of register. MAR, memory address register, store memory that currently be accessed inside RAM. MBR, memory data buffer register, store data from memory. Accumulator, store immediate result from ALU. Program counter PC, store the address of the next instruction. Output units, device which accept information from CPU and convert it into human readable form. For example, when we pay the cashier in the supermarket, he will give a receipt. This receipt is a form of output from the output device known as printer. GIGO, garbage in, garbage out. It is a concept of computer science that the quality of output is determined by quality of input, means wrong input will be result in wrong output. It is related to accuracy of input and output.